Welcome to another edition of Daily Airline News focused on the tragic loss of Air India Flight 171. I'm Geoffrey Thomas, and I'm delighted to say, joined by my co-host, Richard Godfrey in Frankfurt. Good morning to you, Richard, although I think it's now good afternoon.
It's good afternoon here and good evening to you.
It certainly is good evening here. So, viewers, this episode is Engine Shutdown Questioned, episode 237. Huge debate about yesterday's episode with lots and lots of questions. But before we get into that debate, I have a correction for you. Yesterday, I mentioned that Captain Sully Sullenberger was a US Navy pilot, and thank you to King of Rome, who pointed out that is not right. In fact, Sully was a US Air Force pilot. In fact, funnily enough, I'm actually dealing with two US Navy F-14 pilots at the moment on two projects, and one of them actually, his nickname is also Sully, so I got a little bit muddled. But in fact, Sully Sullenberger, when he was selected to join the US Air Force, he went into a cadet glider program. And by the end of that year, he was an instructor pilot in that program. So when he graduated in 1973, he received Outstanding Cadet in Airmanship Award as the class's top flyer. He went on to fly F-4 Phantoms. So thanks to King of Rome for bringing me up to bringing that to our attention. Now let's get into the engine debate with this comment from William Sharp, 5973, who says, what this seems to tell us is that what happened is an event, perhaps even more likely, two or more events, which cannot be calculated in the numbers presented in today's episode. If so, that is another clue to add to the list, something not foreseen at all. Also possible is an event that is not directly connected to the engines themselves in any way, other than it can affect both of them nearly simultaneously. Further, an event that logically would not be included as a failure might be engine commanded to shut down or restart as if a normal event. For AI-171, having both engines interrupted simultaneously where nearly as in is an important clue. This fits the scenario currently still at the top of the list. Water, a single event, nearly simultaneously reaching two locations where the result is nearly two results that combine to be commanded dual engine interruption, shutdown, or relight, restart. This is a scenario unlikely to have been included in the calculations presented today. Richard.
Yeah, a very interesting point. And I've redone the calculations, but I don't think we'll go through them because the numbers are hugely long. The FAA has released three airworthiness directives on water ingress into the EE bays. The first one in 2016, and one this year before the crash, and another one this year since the crash. The first AD 2016-14-04 states that all the electronics equipment in the forward and aft EE bays can be affected. This could cause the equipment in the EE bays to become wet, resulting in an electrical short and potential loss of system functions essential to safe flight. And that's a direct quote from the Airworthiness Directive. The AD also required rerouting the wire bundles near the drip shields above the equipment in the aft EE bay, particularly the aft EE bay, please note. Now, the forward EE bay contains four power panels, two racks full of equipment, four cabinets with further equipment, and a total of 18 systems. The aft EE bay contains three power panels and five racks full of equipment, a total of 33 systems. and they are all connected and throughout the aircraft with a total length of wiring about 60 miles or 100 kilometers long. The number of possible failure scenarios and combination of failure scenarios is a very long number, which has 456,574 digits in the number. So you can imagine how big a number that is. So William Sharp is right. What happened to Air India Flight 171 may well be a failure scenario that no one has ever considered, let alone documented, let alone described how to resolve in a standard operating procedure.
So, Richard, we have these two comments. Phil Bartlett, 7896. Great program as always. As you say, ETOPS has come an awful long way, even from my first transatlantic twin-engine flight on the Britannia Boeing 767. And EDES2QV, thank you for finally distinguishing the difference between unrelated and common cause dual engine failure. It was driving me nuts listening to everyone misusing the dual engine statistics. Keep up the great work, both of you. And Teresa Corrigan, 3076. Electrical problems are very hard to figure out, as our Toyota Sienna taught us a couple of years ago. So, Richard, your comments.
The first twin-engine jet was the Caravelle, which entered service on the 26th of April, 1959. And up through the 70s, ICAO and most national regulators required that a twin jet must always be within 60 minutes flying time at one engine speed of a suitable diversion airport. And the Boeing 767 became a pioneer, opening the transatlantic twin jet services. The first transatlantic flight with a Boeing 767 was made by TWA on the 1st of February 1985, flying from St. Louis to Frankfurt in Germany. But I think, Geoffrey, you got a twist on this one.
Yes, in fact, you're absolutely right with the transatlantic, but the first airline to use a twin jet was actually Trans-Australian Airlines in 1980, flying an Airbus A300 from Melbourne to Perth. And they, the 60-minute rule would have meant they would have had to fly over land the whole way. But the 90-minute rule enabled them to go across the Great Australian Bight. So that was a one-off certification for Trans-Australian Airlines in 1980. But back to you, Richard.
Well, I think we should have a punch-up about whether
Yeah.
Frankfurt or Perth was the
Yeah,
first destination
very,
airport.
very appropriate.
So, coming to the second viewer comment, distinguishing between unrelated and common cause dual engine failure is, in my view, the key to unraveling the cause of Air India 171 crash. We not only have a common cause, but we have a near simultaneous, but not exactly simultaneous common cause. And as the viewer points out, that's a big clue. And fault finding in an automobile may be difficult, but I can tell you fault finding on an aircraft is even more difficult. And when more than one fault occurs and there is a chain of faults, it becomes almost impossible to work out exactly what the sequence of events was.
Mm. Now, talking of ETOPS, we have an interesting one here from Golf 8 Romeo Delta Tango, KLM flight 855, scheduled from Amsterdam to Seoul on the 6th of October 2025, was diverted back to Amsterdam shortly, halfway across Uzbekistan, after departure due to a critical maintenance issue. According to reports, the airline realized mid-flight that the aircraft was for scheduled maintenance that day, which would have rendered it unfit to land at its destination. Rather than risk non-compliance or further complications, the decision was made to return to Amsterdam. Now, this is a strange one, Richard. You've had a look into this.
Yeah, there is actually no official report of the reason. And the next line check maintenance for KLM Flight 855 or the actual aircraft to PHPVC, according to my records, was overdue. KLM Flight 855 from Amsterdam to Seoul turned back over Uzbekistan after 5 hours of flight and landed back in Amsterdam after 11 hours and 6 minutes. The aircraft, PHPVC, was a Boeing 777-300ER. Now, there was no issue with the weather along the planned flight route, so weather was not the reason for the turn back. And the aircraft had been regularly maintained over the last years, and the aircraft did not divert to Almaty International Airport or any other major airport. And there was no pressurization issue with the aircraft because it climbed on the way back to 36,000 feet and on the return leg to Amsterdam. And the usual altitude on the forward leg to Seoul in Korea eventually gets to 37,000 feet after several step climbs. And they were already at 35,000 feet when they turned back. The aircraft had already flown 4,173 kilometers, and it had another 5,443 kilometers left to Incheon Airport in Korea. The aircraft is ETOPS 330 rated and flew 24 hours later transatlantic to Paramaribo in Suriname, South America. So obviously whatever problem there was easily fixed. And I believe there was a slow oxygen leak issue or a cargo fast suppression issue or an APU redundancy issue which forced the turn back, because then the ETOPS 330 rating is invalidated and shortened to an ETOPS 180 rating. And this wasn't an emergency situation. This was an issue which meant the aircraft no longer met the ETOPS 330 requirement. And after Uzbekistan, the flight route takes you over Kazakhstan and China. And from there, from the turnback point, even Beijing was 4,552 kilometers away. Almaty in Kazakhstan was another 1,303, but that is not a KLM Boeing 777 service station, whereas Beijing is a frequent destination for KLM on the 777. And there is no risk in a return to Amsterdam because that route passes 24 major international diversion airports, latest every 15 minutes. So you're quite safe if something does happen, which causes you to declare an emergency. But as I say, this was not an emergency situation.
Okay, Richard. Triple T, Kilo 5, Zulu 3, Mike. I have to say, I think this show is awesome and Richard Godfrey is genius. However, one thing which I do disagree with, and in fact object to, that comes up repeatedly is the root cause being traced to maintenance failures by the carrier, which is often the grounds that Boeing more than often default to when any engineer can tell you that designing a large electrical power bay, which is heavily susceptible to water leaks, means the aircraft is poorly designed, tested, and certified. Putting responsibility on carriers for water leaks to an electrical engine power bay is failing by Boeing and the FAA to take appropriate responsibility and ground all 787s and apply fixes to prevent such fundamentally poor and inadequate design and certification of safety. So why do you constantly point the finger at poor maintenance under such serious circumstances? If you like, Richard, I'll answer this with some facts.
Yeah, because if I answer it, I might get steamed up.
You might. That's why I'm answering it for you. So listen, my dear viewers and dear Triple T. Up to AI 171, the 787 had flown without an accident or a fatality. It has flown for 11 years and carried 1 billion passengers. Over 80 airlines operate the 787. The 787's EE bay design mirrors all aircraft. Every commercial aircraft has EE bays under the floor, from one end of the aeroplane to the other. All designs from all manufacturers have maintenance issues over their lifetime that require ADs and SBs. There are just as many ADs and SBs for Airbus aircraft as there are for Boeing. It is up to the airline to implement them and not forge documents to say the work is done when it is not, or do the work properly. The 787 is operated by the cream of airlines across the globe, and airlines love it. Boeing has sold 2,200 787s, and there are 991 to be delivered. The 787 is the most successful wide-bodied aircraft ever built, outselling the 747 and the 777. Finally, the DGCA found numerous safety-related lapses in its recent audit of the Air India group. So there is absolutely nothing wrong with the 787. You can't blame Boeing. I mean, if there was anything wrong with the 787, the NTSB and the AAIB of the UK would have been down on Boeing immediately with serious repercussions, but they found nothing. So Triple T, I'm sorry, you are not right in your assertions. So there you are, Richard. I spared you that one.
Okay,
Dragonfly.
I will now calm down and carry on with the next one.
So Dragonfly WG6RG did the attempt to retract the undercarriage, set off a complete electrical meltdown of an already compromised electrical system. Richard.
Wow, now here's an interesting one. Uh,
Thought you'd like that one.
landing, landing gear retraction is operated by a hydraulic system. However, the hydraulic system is driven by electrical motor pumps, EMPs. And on a 787-8, the landing gear is actuated by the center hydraulic system, and that's powered by 270-volt DC EMPs. They take around 140 to 150 kilowatt total power if both the center system electric motor pumps are commanded on during retraction for a few seconds. And this is a substantial load on the VSFGs in each engine. But if both engines shut down, then this load exceeds both the capacity of the main battery, the bridge to the APU battery, and even the RAT electrical power. Landing gear retraction is not supported by the RAT essential electrical bus. And when running on the RAT, the system is in survival configuration. Keep the airplane flyable, but not retract the gear. So the RAT only powers the center system primary flight controls. The landing gear retraction attempt could have been the final straw in an already compromised electrical system, as you say. A lot was happening at the same time, however. Aircraft rotation, RAT deployment, then dual engine shutdown. We saw smoke from the vent, landing gear retraction attempt. It is difficult to know exactly at what point the landing gear lever was selected up without the FDR data, which will tell us. It may not have been selected up at all. The preliminary report only states that the landing gear lever was found in the extended position, i.e., the landing gear lever was down. And what we don't know is whether the landing gear lever was moved to the up position and then back to the down position before the crash happened. The report does state that the FDR data confirmed the flap position, but it does not state whether the FDR data confirmed the landing gear lever position or whether the landing gear lever was selected up and subsequently back down. So we have to wait for the FDR data.
Great question. Yeah. So Brett, Juliet 2643, few words are needed with regard to AI 171, a tragic takeoff, a heroic attempt by the pilots to rescue the plane, a totally inaccurate, misleading and shameful preliminary report with the actual CVR and FDR recordings perhaps never revealed. Let's see the full maintenance records for the aircraft for a couple of years before the event. Richard, I think you'll concur with all that.
Yes, indeed. And we have examined the flight and maintenance records for maintenance efforts over 24 hours for the last year of the entire fleet of Boeing 787-8s from Air India. And we've now decided to examine the flight and maintenance records going back over 3 years for the entire Boeing 787 fleet. And depending on what we find, possibly the entire Air India wide-body fleet, 62 Boeing and Airbus aircraft, 777, 787, and A350. And then, if we still are on track in finding issues, we might then consider going through the narrow-body fleet, which is 305 aircraft, A320 and 737. That'll be a lot of investigation work and a lot of data, but we're willing to do it.
Yeah. James Hamlet, Sierra 7 X-ray. Thanks again for your insights. My question is, do you know the status of the apparent criminal investigation and your thoughts? I don't think you've really touched on this subject. Well, we have, but Richard, you can elaborate.
Yeah, and the reason we've only touched on the subject is because there is no credible evidence that the crash of Air India 171 is formally being treated as a criminal investigation at this time. Some aviation safety experts have publicly speculated that the crash is subject to a criminal investigation. There is, however, no definitive public statement from the Indian government, the DGCA, the AAIB, any legal or court sources confirming that Air India 171 crash is currently being handled as a criminal investigation. So we are not going to speculate that there is a criminal proceeding without any official statement.
Michael Barber, 5651, says, absolutely, I agree with you. The facts don't support a murder-suicide. Definitely an electrical issue on an aircraft that is centrally controlled electrically. Electrical issue could be maintenance or failure. Richard.
Yeah, well, if there's a design flaw or manufacturing defect, then there would be a service bulletin SB or an airworthiness directive AD issued as a result. And if there was an immediate systemic risk due to such a flaw or defect, then the Boeing 787 fleet would be grounded globally until the matter was resolved. Now, this has happened before, and it would happen again if required. And if this is a maintenance failure or lapse, then it's the responsibility of the operator, Air India, to demonstrate compliance with its obligations to the regulator, DGCA. And the DGCA has already issued several notices to Air India and levied fines for non-compliance on safety oversight matters. The AAIB is supposed to act as an independent investigator, independent of both the operator, Air India, and the regulator, DGCA. But that is not the case here, as there are 3 employees of the DGCA currently involved in the AAIB investigation. This constitutes a clear conflict of interest and contravenes ICAO Annex 13 requirements, which India has committed to uphold as a signatory. The Minister of Civil Aviation, therefore, has a duty to ensure the AAIB is structurally and functionally independent. The investigation should be conducted in line with the ICAO guidelines, free of regulatory capture, and that India's international commitments in aviation safety are fully respected.
Absolutely. Craig Novy, 2090, hats off to Mr. Godfrey for meticulously making the case again for his hypothesis of the crash. Keep in mind the contents of this channel can be obtained free of charge to anyone who can get on YouTube. We in this community wait for someone in the know to counter this, not just with sentiment, but actual, accurate, factual data. The silence of no meaningful official negative response to this hypothesis is telling. I think you might agree with that one.
Yes, I do. In fact, Craig, we've pointed out water ingress and our hypothesis in 32 different episodes. So it's a bit difficult to miss unless you're really trying to avoid it. And I would add, too, that we have sent 2 letters to the AAIB requesting clarification of key issues in the preliminary report. So I think they're well aware of what we are saying. And yes, you say the silence is, deafening.
So Mike 747436, you mentioned that the captain of AI 171 could have chosen different, perhaps more obvious ways to bring down the aircraft if that was his intention. Could the same not be said of the captain of MH370, who almost certainly hijacked and crashed his aircraft by means of a complex and carefully constructed plan to avoid detection? When someone is crazy enough to carry out something like this, logic and norms no longer apply. Interesting point, Richard.
It is indeed. AI 171 crashed 32 seconds after takeoff. MH370 continued flying for 7 hours, 32 minutes, maybe longer. There is evidence that VTAMB malfunctioned. The RAT deployed, 2 engines shut down, an aircraft crashed shortly after takeoff in a densely populated area close to the airport. There is no evidence that 9M MRO malfunctioned. The aircraft flew until fuel exhaustion in a remote location, 1,566 kilometers from the nearest airport, which is Perth in Australia. VTAMB crashed in full view of hundreds of witnesses and is captured on several CCTV cameras. 9M MRO crashed without witnesses and was not captured on any camera. And as you say, logic and norms no longer apply. And that's why we need to find the wreckage of MH370 and the FDR, which will still be readable after all these years. And I would point out that MH370 flew past three diversion airports, went past Port Hedland, which has a 2,500-meter runway, and that was 2,120 kilometers before the crash site. It went past Cocos Keeling Islands, which has a 2,441-meter runway, and that is 1,911 kilometers before the crash location. It went past Learmonth, which has a 3,047-meter runway, and that's 1,610 kilometers before the crash location. So plenty of opportunity to divert to an airport if that had been the goal, and it obviously was not.
Mm. So, Richard, from Padre John Ruffle, my takeaway from today's episode is not a pizza, but Richard's highlighting of a common cause dual engine shutdown. Some months ago, the discussion centered for a while on whether a common cause event could have been triggered by an electrical or software glitch within the pedestal affecting the fuel cutoff switches. The general consensus was that such an event would be incredibly unlikely or nigh on impossible. However, as we have moved on with Geoffrey and Richard's analysis of available data, the focus moved to the aft EE bay and possible water ingress from faulty lavatory couplings. From a common cause being ruled as impossible by some form of common cause scenario is now highly likely. My point being that when anyone rules out an event scenario as being impossible, a whole array of red flags goes off in my mind. Finally, while I appreciate the statistics, human error can turn the numbers on their head in less than a single minute, tragically. So we wait for transparency over the maintenance logs. Richard,
Yeah.
interesting observation.
It is indeed an interesting observation. And I think of never say never. Um, I think it's good to ask instead what it would take to make the impossible possible. In the case of Air India, there were only 32 seconds to turn the numbers on their head. And we have not yet proven that this was a human error or not human error. We have presented a plausible hypothesis of human error in the maintenance chain. We are open to investigating all possible causes of the crash, human, machine, external, environmental, or whatever kind of possible common cause. A common cause is required to match the observed dual engine shutdown. A time-related common cause is required to match the observation of a near simultaneous dual engine shutdown. And as we pointed out earlier, we're not willing to wait until the maintenance logs are published, nor are we willing to wait until the FDR, CVR, and ACARS data is published. We're going to investigate the last 3 years of flight and maintenance data of VTAMB and see what that reveals. And depending on what we find, we might investigate further to see if there was a systemic fleet-wide maintenance issue.
Yeah, absolutely. That'll be a very interesting exercise, Richard. Now, Falsindo, I hope I've got that pronunciation right. I probably haven't. I apologize. Gents, the South Pole was briefly mentioned in this episode. Do you find it strange that Antarctica is essentially a no-fly zone because of ETOPS requirements, yet flying over vast oceans is allowed? if it was up to me, I'd take my chances landing on a frozen wasteland over sinking into the ocean depths, lost forever, a la MH370. Thoughts, Richard?
Yeah. Either option is not that appealing.
No.
The issue with the Antarctic is that, unlike the Arctic, there are no major population centers surrounding it. Now, airlines have flown over the North Pole for decades to connect Europe with North America, and then the east coast of North America with Asia. And more recently, even the Middle East and India with North America on direct flights. There are, interestingly, 6 ice runways in Antarctica. But the issue is not landing a plane, it's accommodating the passengers if a forced landing is required. And you don't want to be sitting outside in the cold in the middle of the Antarctica. So, Geoffrey, you've done some sightseeing flights to Antarctica. Can you give us details about those flights?
Yes, Richard, I've done a few. I've done, in fact, three on Boeing 747s and Qantas's. They do about 7 or 8 flights every summer to the Antarctic, to Antarctica. And it's really interesting. And the first one I did, I was actually part of the crew and went through all the briefings beforehand and found that on board they've got on the 747 they had about 400 passengers and they had on board special survival provisions. They also had on board special suits for all the passengers in case they landed in Antarctica against the cold. So there was all sorts of provisioning for the flight. And what they also did as well, the minimum equipment list was zero. In other words, every system had to be working on the aircraft or it wouldn't be dispatched. And these flights lasted about 14 hours. And it's a fabulous day out, and they still do them. They're now using 787s, twin engine 787s, on a 14-hour journey, and they operate them out of Brisbane, Sydney, Melbourne, and Perth every season.
I
So,
think I'll stick to flying to the Caribbean. It's
yeah.
warmer.
Chris P, 6072. Your explanation of ETOPS was fascinating. In 1955, my dad, who was an RAF S-55 helicopter pilot, was posted to RAF Kuala Lumpur. My mum and I followed in an airwork Handley Page Hermes from Blackbush, formerly RAF Hertford Bridge, in Hampshire, UK, to RAF Changi, Singapore. It took 5 days. The aircraft flew over land wherever possible. We flew back in an RAF Hastings, landing at Lynham, also taking 5 days. The most dangerous part of the journey was the train between Changi and KL, which was often attacked by communist terrorists. A bit of a diversion, I know, but it does demonstrate the huge progress made in civil aviation. Now, Richard, the period he's talking about was called the Malay Emergency,
Mm.
where the British, Australians, and some other Indians, I think, as well, were fighting off communists in Malaya in the 50s. But an interesting
Uh,
story.
it's a great story, and thank you for that, Chris. And one of the fascinating aspects is that the more powerful the piston engines became, the less reliable they became. And on aircraft like the DC-7 and the Lockheed Super Connie, it was a failure every 3,000 hours. And when you think about how that compares with today's current one shutdown with 100,000 flights for a jet powered, like a 777 or a 787 or a A350 or an A330. And the GE90 engine has now been documented as achieving one shutdown per million hours in service, far better than the requirement. and the GENX, which is on the AI 171, is heading in the same direction. And the Trent XWB engine has consistently shown very low IFSD rates, this in the same band as the GE90 and GENX. And in contrast to piston engines, the more powerful jet engines have become, the more reliable they have become. And that just shows you the huge advances in technology and in material science, like ceramics, single crystal super alloys for turbine blades eliminate grain boundaries, boosting high temperature strength. And ceramic coatings protect blades, and ceramic matrix composites are now used in hot sections of an engine. They cut weight, but they tolerate even higher temperatures.
Jacqueline Jacobson, 6789. Thank you for providing those odds. I'd rather win the lottery 10,000 times than face those odds as a passenger, even though remotely minuscule. But as you explain, with a dual engine failure linked to a common cause, I guess I'll just be happy with winning the lotto once. I think we all would be happy with that, Richard.
Yes, I think we can all agree with you, Jacqueline, on that one. And then if we win the lottery, we could hire a 787 and go on holiday with the friends and family somewhere.
Yeah. So Robert Koch, KOK, good afternoon. Geoffrey Thomas, you talked about the book ETOPS Twin Through Time from Airbus. I can't find anything about the title, or can you put a link in your post, please? So, in fact, it wasn't a book, Robert. It was a book for sale. It was rather a marketing booklet they put out. Now, I gave my copy to a gentleman named Mohan Pandey. He was a Boeing engineer in, in charge of operational regulatory affairs, and he used the data in from this brochure in his book, How Boeing Defied the Airbus Challenge. It's all about ETOPS. And there's a link below to his book. It's a great book. I've got that book. However, I took a photocopy of the marketing booklet before I sent it, and I have now put that into a PDF, which I can send to anybody who's interested. And my email is below in the description. So if you'd like to see that booklet, send me an email and I'll send you the PDF. It's a 38-page PDF with a whole lot of fascinating numbers to have a look at. So, Richard, that's all we've got time for. I think we're actually over time. So thank you very much indeed for all the work you've done.
Yeah, you're very welcome.
Yeah. And viewers, Richard and I are taking a day off tomorrow, but we'll be back on Sunday, and we'll be back with a very interesting story. I think you're really going to be fascinated by it. It relates to the 737 MAX, although it relates to a lot of things today. It's all about the media reaction to that story and all the mistakes the media made. And so I think you'll find that very, very interesting indeed. So that's what we will be doing on Sunday, and we do look forward to your company. So look, do please subscribe to us, please like us, please keep those wonderful comments coming. We do appreciate them, and keep the great questions coming. And Richard, once again, thanks for all your effort. This was a fantastic episode.
You're very welcome.
And viewers, do have a great weekend, and we look forward to your company on Sunday. Take care.